In this lecture, we're going to take the next step from looking at individual angles to defining some relationship between pairs of angles. For example, two angles like angle DBA and angle BAC, where the sum of their measures is 90 degrees, are what we call complementary angles. And you can tell that's their sum because the larger angle, DAC, that's made up of those two smaller angles is a right angle. And by definition, the measure of a right angle is going to be 90 degrees. Now, if we have two angles and the measures add up to 180 degrees, then we'll call those angles supplementary. In this case, I know that the sum is 180 degrees because I was explicitly given the measures of the two individual angles. Now, notice how in this case the two angles don't have any sides or points in common. I drew them that way in the first example to illustrate how you can, in a sense, combine two complementary angles together to get a right angle. Well, you could similarly think of two supplementary angles as being something you could combine together to get a straight line. There isn't anything in the definitions that says the angles have to have any parts in common. And finally, we'll say the two angles are adjacent if they have a common vertex and a common side. So looking back at the first example, angles DAB and BAC are two complementary angles, are adjacent since they share the same vertex, A, and the same side, AB. Now, on the other hand, in this diagram, the two angles aren't adjacent, even though they share part of a side in common because they don't have a common vertex. So I've got a few quick questions for us to look at here to kind of illustrate these two properties, complements and supplements. So the first thing I want to know is what's the complement of a 42-degree angle? Well, I know complementary angles add up to 90 degrees. So if I let x be the angle that I'm looking for, then x plus 42 degrees has to equal 90 degrees. If we solve this equation, subtract 42 from both sides, we get x equals 48 degrees. Now, I set this up as an algebra problem because students are generally familiar with algebra and algebra word problems and that kind of thing. But there's going to come a point where with a question like this, they really don't need to go to all that the trouble of setting up an equation, right? It'll get to where they can just kind of look at this and say, well, look, I know it's what's left from 90 degrees after I take that 42 degrees out, and they'll just jump right to look. It's 90 minus 42, which is 48. And that's great. That really is the point where you want people to be at the end of the day. All right, so the next question, what's the supplement of a 42-degree angle? Remember, supplements add up to 180 degrees. So I'll kind of use the short version here and say, well, it's 180 degrees minus 42 degrees, which is 138 degrees. And there's your answer. Okay, and finally, what's the complement of a 112-degree angle? Well, if we use our shortcut method here, this is 90 minus 112, which is negative 22 degrees. Now, there are times when we are going to want to talk about negative angles. In trigonometry, for example, a positive angle would represent something that's moving in a counterclockwise direction, where a negative angle will be something that's rotating in a clockwise direction. And that's fine, but geometry really very much has its roots in being a practical subject. It was used to talk about physical things like architecture and surveying problems. So because of that, in geometry, we generally don't want to talk about negative angles or negative distances either. Right? So when we run into something like this, my answer would be that angle actually doesn't have a complement. So suppose I have two lines, right? And these two lines are going to cross each other. When that happens, the two lines form four angles, right? I'm going to number them, right? Because this is going to be one of those cases where just referring to them by number is going to be a lot quicker than trying to talk about the individual points, right? Each pair of opposite angles are called vertical angles. So looking at the diagram, right? The vertical angles here would be angle 1 and angle 2, and angle 3 and angle 4. And each pair of adjacent angles is called a linear pair, right? So there's actually four of those. Angle 3 and angle 2 are a linear pair. Angle 2 and angle 4 are a linear pair. Angle 1 and angle 4, and angle 1 and angle 3. Those are also a linear pair. So I've got another example for us to look at here. And we've got a situation where we've got two lines that are crossing. So we've got a bunch of vertical angles, a bunch of adjacent angles. And I know the measure of one of them. Right? Measure of angle 1 is 35 degrees. And what I usually do when I have a diagram and I'm given information about it, I'll actually write that information right there in the diagram. What I want to know is what are the measures of the other three angles. Right, well, if you look at angle 1 and angle 4, those angles together make a straight line. And the measure of a straight line is 180 degrees, straight angle, if you will. So those two angles have to be supplementary. That tells me angle 4 is going to be 180 degrees minus 35 degrees, which is 145 degrees. I'm going to do the same argument with angle 2. Angle 2 and angle 4 form a line, so they're going to be supplementary. That makes angle 2 180 degrees minus 145 degrees, which is 35 degrees. And finally, angle 3. Well, angle 3, we could do this either way with angle 2 or angle 1, supplementary with both of them. So angle 3 is going to be 180 degrees minus 35 degrees, which gives us, again, 145 degrees. Okay. Notice the pattern that turned up here. 3 and 4 are vertical angles, and they have the same size. 1 and 2 are vertical angles, and they also have the same size. That's not a coincidence. Right? Vertical angles are always going to have the same size, and in geometry, we actually have a term for that. Two angles or segments, we can talk about this with segments as well, are said to be congruent if and only if they have the same angle measure, right? Or again, if we're talking about segments, if they have the same length. So we're talking about angles. We're looking at two rays, or we can think of it as two lines if we extend the rays into lines that cross each other. In the next lecture, we're going to start to look at what happens when we have a situation where there are two lines that don't cross each other.